sbRIO 9636 up and going right now. And what I'm going to do is I'm going to show you how to go through the entire process of connecting up to it, getting the real time onto your project. I'm also going to show you how to do the Fpga onto your project. And then after showing you the Fpga, I'm going to also show you how to connect, bring in I/O from the Fpga, and then take that I/O and bring it to your real-time controller. Now, you cannot take I/O from the real-time controller to the computer directly. You have to use, there's a couple different ways you can do it. Network streams tends to be the best way of doing it, but I'm not going to go over that today. But I'm mainly going to be focused around the sbRIO. All right?
Okay.
Okay, so let's start a project. My mouse is going a little nuts here. So I use LabVIEW 2015 for this. 2015. There you are. Okay, so it takes a minute to start up. In order to do this, you have to have the real-time toolbox on here, and you have to have the Fpga toolbox. If you don't have either one of those, you will not be able to program an sbRIO, or an sbRIO, if that matter. Let's see, we're going to use the regular LabVIEW right here. You start LabVIEW. I'm going to create a project. Now, you've got quite a few templates that you can use. You know, you have a MyRIO and some other stuff. What I would recommend is just start with a blank project. Now we have a blank project. As you can see, we have My Computer. Now, that My Computer is a target for your software program. We don't quite have your sbRIO, so we need to, I'm sorry, your sbRIO. So we're going to put a target in device, say new target in device, open that up, and so we have a real-time single board RIO. What this is going to do is going to look at my network and look to see what hardware devices I've got. This one was an RFID system that I was using many moons ago. So that's what I'm going to select. Click OK to discover the chassis. And once it discovers it, there you go. You're on there.
This is if the board is already connected to the computer, right? Or network?
Yeah, it's got to be on the network. Otherwise, if it's not there, you're not going to be able to find it.
Okay. Now,
you can add one if it's not connected. Say you're going to connect one later. You can connect it. The IP address will be 0.0.0.0.
Right.
So
I was able to do that actually. So I've been setting up a little bit of stuff, making classes and playing around with it a little bit. So I just did it as an empty, no target device because I don't have it yet.
So very good. Yeah. Sometimes on the compact RIOs, you have to add the Fpga targets. This one I did not have to, but if you needed to, what you would do is you would go to the actual sbRIO target, right-click, and say New, and then you would also have to add a target, or add, sorry, not new, add a target. But this one we don't need to, so that's good. You have quite a few analogs and quite a few digitals right here, as you can tell. So if you want to create an Fpga, some code for your Fpga, you have to write, you'll have to say new VI, and you bring up the VI. All right. So simply put, you can simply drag and drop your analog or your digital on here. It's very simple. Now notice the colors. The colors we have for this are gray. So if you take a look at what that is, what gray is, it's a fixed point. You see that? So what I did was I created, you can either create, you right click on the actual terminal there, you right click, and you can say, okay, I want to create a constant control or indicator. There's your indicator. And then if you hit Control H, which is help, it brings up this context help box, and then it'll tell you what it's called and what type it is. Now, what that means for you is you're going to have to convert this fixed point to a double, single, or whatever other type of variable you're going to use. And that generally is not that hard. It's just, going in and doing a conversion. What I need to do is show you how to take this and put it into a sbRIO code. So you'll go in here, you'll say new VI for your RIO. So the difference is this one's for the actual controller, this one's for the FPGA. And what you should do is you should save this as your FPGA code. So I don't know, I'll have to eventually save this, because once I save it, LabVIEW will be able to identify what to do with it a little bit better. So let's go ahead and go through that process of saving. So I'm going to save the project. I'm just going to put this on the desktop for now. Just FPGA example. FPGA example. And then this will be FPGA code, so I'm going to put it in here. And this one will be the RIO code. There we go. There we go. So now we have the FPGA, and you can see underneath the FPGA there should be the FPGA VI. So we're gonna go ahead. I'm gonna make a control indicator. I'm gonna save that again. Control S. And what we should be able to do. If we do a Fpga Interface, I believe, let's think here. So what we were originally going to do is we were going to do a FIFO on this, and we don't necessarily need to do that now. Now that we have these here, we should just be able to connect this straight up. So if you have a while loop, and we never want to stop this, and then we put a timer on here, obviously, because we don't want this thing to go forever. Ticks, milliseconds, 8 bits, and we'll do this for 10. Now, let's just go over this really quick. So what I did was, you have a counter unit here. You can use ticks, microseconds, and milliseconds. I'm going to slow this down pretty good. So that's milliseconds. You're probably going to wind up using ticks or microseconds because some of the things that you're going to be doing are going to be very fast. Now you should be able to configure this. There are property nodes to this timer that you can modify if you need to. But honestly, I probably, if I were you guys, with the super fast speeds that we're asking, you might want to stick with microseconds. I'm using 8 bits because I really don't need high precision, right? So, all right, so that's, if you go in, you press the oops, not that button, you don't want to use that button, you want to use the screen button, the arrow. So this, with the arrows going around and around, that means run forever without regard to what the stops do in the while loops. So use locals. If we do local compiler, it'll compile it up for us. To compile an FPGA takes forever. you're probably looking at, for something like this, you're probably looking at like 10 minutes. So, and then while you're doing that, you can't do anything else with LabVIEW because it's thinking. So I'm going to go ahead and cancel out of this after it gets done with stage 5. All right, there you are. All right, I'm going to go ahead and close that out. Now, what we should be able to do is we should be able to identify or grab these guys in our real-time code. So if we go in here, and what we need to do is we need to put the Fpga, Fpga Interface, I did click on you. There it is. It's just not going down all the way. So we have this guy. This is our Fpga interface. What this allows you to do is you drag that in here, and now you have that direct selection. So this guy right here is what links your Fpga to the sbRIO. Oh, sorry, sbRIO and sbRIO controller. So now you have direct access to these guys. And it makes it a heck of a lot easier because once this gets written, you'll have the latest on your controller. So what you can do, what I would do, is if you're going to do any filtering or averaging or any of that nature, you're going to take this code right here, you're going to maybe take in 10, 20, 30 samples, filter it out, push it to a double, and then on this side, instead of saying AI 0, what you'll have is that filtered double, and your output this, and basically that's let your controller do all the thinking and let your FPGA do all the low-level signal processing. So essentially what you have here is a DCS system. So very simple, very quick, and I feel like if you do it a different way, I think it overcomplicates for what we're trying to accomplish.
Cool. Sounds good.
So yeah, and like I said, it's faster too. So otherwise, you're gonna be troubleshooting all this other stuff that you don't need to troubleshoot. Just bust this out.
Whenever you're pulling in through different channels, through different ports, should we be pulling those in at the exact same time or looping through them? I know the hardware is going to multiplex it anyway, so I just wasn't exactly sure how the
So I would group these. Yeah, so what I do is I group these. I'll take a while loop, and so for example, for your project, I'm going to do a visible item subdiagram. Okay, so this is going to be your current sensing, your analog input current sensing loop. Okay, so this one, you don't need to make that really fast. Oh shoot, I don't want to do that. You don't need to make that very fast. Essentially, this can be, let's do it this way. 25. We'll make it 25, and then what you'll do is you'll bring in. Let's take this. Let's make this. Let's say AI 1. I'm sorry, 0 and 1 are your current sensing. So we're gonna change this to 2. We'll make this 0 and 1. Actually, you don't even need to separate those out. You can bring those down. So AI 0, AI 1, those are your current sensing, and what you can do. This is answering a question, but it's also demonstrating something else too. So what you can do is you can take these in, and you can, we want an array, that's what we want. Build the array. So you build the array, do this 10 times. So let's do it this way. So what I'm doing here is I'm taking 10 elements, and I'm going to, actually this is the wrong way of doing it, my bad. This needs to be inside here. You're taking 10 elements and you're making them into an array, and then on this side of the array, you can do it this way too. Let's kill this, kill this, kill that. One way of that. We'll do it this way. Click. Put this guy inside here. And then on this side, on the right side of this guy, what you can do is you're filtering or whatever you need to do. You're averaging however you want to do it. So you're taking 10 samples at 25. Let's make this super fast, microseconds, and then filter it, and then push it to a double to go to your controller. So, and then of course you have this loop to answer your question, Jordan, to go back to your question. These can be your A3, there we go. These can be your other analog channels.
Right.
And then you have another one for your digital channels. And then if there's, so do you remember how you, on your documentation, you have the classes of analog inputs, analog outputs, digital ins, digital outs, that type thing? So what you can do is you can mimic that in your Fpga code. And I would probably add the additional AI and say, okay, current sensor. Just add another class called current sensor, and then there you go. You've got all your inputs and outputs that you're going to be doing.
Cool.
What happens is if you put all your inputs and outputs on the same loop, they're going to be deterministic on whatever happens with all the other inputs and outputs. So, and with FPGA, man, everything's a parallel process. So
okay.
it's all gonna. The only thing that would be holding it back would be the actual programming itself.
Right.
So you're in really good shape if you make sure you move forward with that.
Cool. So for FPGA, really, we just need that one single VI, and then the other logic we'll just worry about on the controller side, the real-time side.
Yeah, most of the time, yes. You can still do sub VIs for any of the processes. Like there may be some things that you share between the two analog input type loops, but yeah, I mean that's basically it. Just do an FPGA main that captures all your inputs. You don't need multiple VIs to capture your inputs.
Right.
So okay, and then of course. See here, we have, I'm trying to think if there's anything else that we need to talk about, because honestly, this was it. I mean, it was really very straightforward. We pull this, you can grab anything that, whenever you place an indicator on this side, an indicator is an output, whenever you put your output on here and you save it, then you're going to have access to it on your controller. And so, however you want to access that, that's fine. But you've got to make sure that you have this guy, this FPGA target plugged in. Mm-hmm. Otherwise, it's not going to know what you're talking about.
And will you have to pull in that target for every single input?
I would just
pull it once and then.
Honestly, yeah, I would only do it once, because if you do it multiple times, LabVIEW might get confused. I've never ever really done more than one. I always had one reference to it, and I was just very cautious in how that works. I know how LabVIEW sometimes gets kind of funky, does some weird tricks sometimes, gets confused very easily. So.
And then once you would take these values, the way that I have it set up right now, I have like a class, like doubles and things like that in the class control. So would you recommend like pushing those values into the class and then using the class for the rest of the logic, like scaling and all of that stuff?
Absolutely, absolutely. Bring those raw values into the class, and then, or actually probably call it the object at that point in time. So bring that into the object so you can manipulate it nicely, and that way you can separate those objects out nicely.
Okay.
Definitely bring the raw into the object though, for sure.
Cool.
Because it'll help you when you get down to it and you're troubleshooting. If you've got those values into the actual object, you'll be able to trace where the logic may have gone awry.
Right. The value in the class or the object is just going to be just a single double for that particular value, and then I should write it to the file. So I'll just do it each individual reading, right?
Yeah.
I don't necessarily need an array of, like I'm thinking FIFO type or like some sort of buffer so that if it's not writing fast enough or, you know, if the timing is off, but it should be plenty fast enough to just do individual value, write it to the file, go through, pull the next one.
You know, one other thing you can do if you really want to, you can have your FPGA go as fast as you want it to go, and then you can always just have it extract the values when you need it. So the FPGA will always have an update for you. It's just you choose if you want it or not. So that's another way of doing it. It's a little sloppy, but you know it's fine. It'll work. It does the job.
Mm-hmm. I'm just thinking to try to get the read speeds that you were asking for. It's going to be really quick, so just have to play around with it, I guess. I just have questions whenever I have questions.
The other thing you can do also is you can always make this into an indicator, or I'm sorry, a control. So if I save this, I should be able to have access to it. So bear with me for a second. I'm going to save that to the FPGA. I may have to, sometimes in the earlier LabVIEW platforms, I've had to go in and re-update this, like blow it away and put a new one in. Let's see if it works this time. Yeah, it worked. There you go. So there you go. You can always update the counter right here.
Right.
Yeah, 2015 is the way to go. I like that.
Yeah, because we want to have it user programmable, the sampling speed, so.
Right. Well, I mean, there's a lot of different ways to skin a cat, you know, and honestly, this would be the cleaner way, even though it takes a little bit more programming to do. It's actually the better way of doing it because you're not stressing the FPGA out all the time. If you're taking 150,000 samples all the time, that hardware is going to get worn out. Yeah. So yeah, that would be the better way of doing it. So.
Cool. Well, it all makes sense. Definitely clarified a lot of just initial questions.
Did you need, you know, one thing you can also do is if you want to share that repository, what I can do is I can kind of, you know, write notes. Like, for example, if you know, have something here, I can sit there and say, you might want to consider la, you know. Yeah. So whatever. I mean, I can do stuff like that. So if you want to just provide that. But honestly, I think if you do it this way, you'll be perfectly in line with good programming practices. And then, of course, you know, make sure all your while loops have timing mechanisms in there. I think that's about it, honestly. It's pretty easy. And like I said, you know, you can always simulate, you know, get everything ready to go, and then when I get the electrical stuff all squared away, then you know, I'll be more than happy to hand over this 9636, and you guys can just, you should be able to take whatever program you do and just push it. Right. And then of course, if there's any problems that you run into, you know, give me a shout and I can take a look at it, and you know, if I need to make some programming modifications so that there's issues that can be resolved, and I'll be more than happy to do that too.
Cool. Well, that sounds good. Sounds like a plan.
Okay. While I have this up, any questions regarding LabVIEW and development?
Can't think of anything right now.
Okay. Let me think. Does the computers at the school? It's got 2015. You said, right?
It does.
Okay, and so do they have, they've got the real time and the FPGA stuff going for them?
So actually, I had a question about that. I don't know if they do. For the actual LabVIEW project, I was talking to one of the TAs, and he said as long as you push the whatever, I guess he was saying drivers and stuff to the board, you should be able to still program in it, in that environment.
It's going to be pretty straightforward. So in your functions palette, so you go to your block diagram here. In your functions palette, what you're going to see is your real time and your Fpga interface. If they're not there, they don't have it. The other thing is, when you start up LabVIEW, so let me see if I can start up another LabVIEW 2016 or something of that nature. LabVIEW 2016, when you do, let me see if I can, when it pops up, let me see if I can do a screenshot. Maybe. Okay, there it goes. All right.